Hello boys of class 8 আজকে আমরা এক্সারসাইজ 10.2 করব যেটা অ্যাকচুয়ালি সার্কেল থিওরাম রিলেটেড এক্সারসাইজের মধ্যে আছে 10.2 এর নাম্বার 1 যে প্রবলেমটা সেটার জেনারেল ইনিশিয়েশনটা অনেকটা এরকম if two equal chords intersect each other inside the circle the segment of one chord are equal to corresponding segments of other chord. So figure ta erokom particular illustration ta ekটু দেখি. Let in the circle PQRS the at center M PQ and RS are two equal chords. So এখানে বলে দেওয়া ছিল দুটো equal chords থাকতে হবে. So PQ and RS are two equal chords. Both chords intersect each other at O, which is inside the circle. It is equal to show that PE equals to RE and QE equals to AC. So একটা chord কিছু সেগমেন্ট আর একটা chord সিমিলার একটা সেগমেন্টের সমান এটাই আমাদের শো করতে হবে. সো কনস্ট্রাকশনে চলে আসি. Draw perpendicular MN and MO from M to PQ and RS respectively. Join ME. প্রুফে স্টার্টে কি প্রথমে দেখি. Since MN is perpendicular on PQ and MO is perpendicular on RS and ME is joined, so you can say MNE and MOE are right angle triangle. So the right angle triangle এর একটু যদি খেয়াল করি ME equals to ME because this is the common side in both triangle and actually this is hypotenuse. MN equals to MO, both are perpendicular distance from center to chords and we know that distance from center to equal chord is equal. তাহলে রাইট অ্যাঙ্গেল দুটো রাইট অ্যাঙ্গেল ট্রায়াঙ্গেলের মধ্যে যদি হাইপোটেনাস এবং আরেকটা সাইড ইকুয়াল হয় তাহলে আমরা বলতে পারি দে আর congruent. So triangle MNE and MOE is congruent. So we can say NE equals to OE. Now since MN is perpendicular and MO is also perpendicular, so N is the midpoint of PQ and O is the midpoint of RS. So we can write PN is equals to half of PQ and RO is half of RS. এখন PN since PQ equals to RS equal chords, so half of PQ equals to half of RS. So we can write PN equals to RO. যেহেতু PN equals to half of PQ and RO is half of RS. Now PN can be written as PE plus NE and RO can be written as RE plus OE. আমরা একটু আগেই প্রুফ করেছি NE equals to OE. So এই PE থেকে যদি আমরা NE আর RO থেকে যদি OE বাদ দিই তাহলে থাকছে PE equals to RE. So we can easily write PE equals to RE. আবার আমরা যদি PQ equal to RS যেহেতু জানা আছে, সো আমরা PQ থেকে PE এবং RS থেকে RE বাদ দিয়ে দিই, যেখানে আমরা একটু আগে প্রুফ করেছি PE এবং RE সেম. সো সেম পোর্শন যদি আমরা দুটো থেকেই সাবট্রাক্ট করি তাহলে কি পাবো? PQ থেকে PE চলে গিয়ে থাকবে PQ থেকে PE চলে গেলে থাকবে QE এবং RS থেকে RE চলে গেলে থাকবে SE. সো এখানে প্রুফ হয়ে গেল QE equal to SE. Thus PE equals to RE and QE equals to SE. Now in number 2, general enunciation is given. Prove that the bisecting points of equal chords lie on a circle. So equal chords are যে bisect করে যে পয়েন্টগুলো, দ্যাট মিন্স মিড পয়েন্টগুলো, ইকুয়াল chords এর মিড পয়েন্টগুলো একটা সার্কেলের মধ্যে থাকে. তার মানে সেন্টার থেকে তাদের ডিস্টেন্সটা সেম। ওকে, so particular enunciation, let in the circle A B E F D C, O is the center, A B C D and E F are three equal chords, and M N and P are their midpoints respectively. It is required to prove that M, N and P lie in the same circle, or we can, in another words, we can say OM equals to ON equals to OP. Now join OM, ON and OP. Since M is the midpoint of AB, so we can write OM is perpendicular on AB. Similarly, OP and ON are perpendicular on EF and CD respectively. As we know that AB, CD and EF are equal, so we can also say OM, ON and OP are also equal, because they are equal, their distance from center to equal chords. So when we'll draw a circle of radius OM or ON or OP, all the points M, N and P will lie on the circumference of the circle. So it is proved. Now number 3, show that equal chords drawn from the end points of a diameter are parallel. At first এভাবে একটা ফিগার ড্র করে নিই, পার্টিকুলার ইনিশিয়েশনটা দেখি। let AB be a diameter in a circle centered at O. AE and BF are two chords drawn from the endpoints of AB respectively. That means AB এর A endpoints থেকে AE and AB এর B endpoints থেকে BF দুইটা chord draw করা হয়েছে। We have to prove that if AE equals to BF, then AE parallel to BF. Construction, join OE and OF. Now in triangle OAE and in triangle OBF, AE equals to BF, it's given that they are equal chords. OA equals to OB, since they are radius of same circle, and OE equals to OF, they are also radius of the same circle. So we can say three side of a triangle is equal to another three side of another triangle, so they are congruent. So triangle OAE and OBF are congruent, so we can write angle OAE from triangle OAE is equals to angle OBF in triangle OBF. But this angle OAE can be written as angle BAE and OBF can be written as ABF, which are actually alternate angle, and they are created when AE and BF are connected by the line AB. So as they are equal and they are already alternate angle, and we know when alternate angle are created, when some parallel lines, when a pair of parallel line is intersect by a third line, then alternate angles are equal. Since they are equal and they are created as alternate angle, so AE and BF should be parallel line. So that's it, the proof done. Now in number 4, show that parallel chords drawn from the end points of diameter are equal. It is actually the converse proof of number 3. Similarly, we have started, let AB is the diameter of a circle centered at O. AE and BF are two chords drawn from the endpoints of AB respectively. And earlier in number 3 we have proved that AE and BF were equal. We have to prove AE and BF are parallel. Now we have to prove if AE and BF are parallel, then AE and BF are equal. Now construction, similarly OE and OF are joined. Now since AE and BF are parallel and AB is their transversal, so we can say angle BAE is equals to angle ABF because they are alternate angle. Now BAE can be written as OAE and ABF can be written as OBF. Now in triangle OAE, OA equals to OE because they are radius of the same circle, and we know if two sides of a triangle is equal, then their opposite angles are also equal. So angle OAE equals to angle OEA. Similarly, OB and OF are also equal as their radius of same circle, so we can write OBF and OFB are equal. Earlier we have written that, or we have proved that angle OAE is equals to angle OBF. Now we can write, instead of OAE we can write OEA, and instead of OBF we can write OFB. So it is proved angle OEA and OFB are equal. Now if you look in the figure, this angle equals to this angle, this angle equals to this angle. Now already two angles from both triangle are equal, so third angle should be also equal. So we can write angle AOE equals to angle BOF. Now in the both triangle, OA equals to OB, same radius, OE equals to OF, radius, and included angle AOE equals to angle BOF. So we can write both of the triangle are congruent. So from two congruent triangle we can write AE equals to BF. That's the proof. Now number 5, actually this is close to our theorem 3 and 4, where we have doing equal chords and are from equal distance, and this is almost like same. Prove that between the two chords, larger one is nearer to the center than the smaller one. That means chord যেটা বড় হবে সেটা সেন্টারের কাছাকাছি হবে, chord ছোট হলে সেটা সেন্টার থেকে দূরে থাকবে। Particular enunciation একটু দেখি। Let AB and CD are two chords in a circle centered at O, where AB greater than CD, and OE and OF are the perpendicular distance from O to the chords AB and CD respectively. So এখানে বলেই দেওয়া আছে OE and OF হচ্ছে perpendicular distance from O to AB and CD. It is required to prove that OE less than OF. Then that means O থেকে E এর distance O থেকে F এর distance হচ্ছে কম. Construction, join OA and OC. Since OE is perpendicular on AB and OF is perpendicular on CD, we can write A equals to B equals to half of AB and CF equals to DF equals to half of CD. Since AB greater than CD, as we have already said, AB is the larger chord amongst AB and CD. So AB greater than CD, so half of AB should be greater than half of CD. Now half of AB means AE and half of CD means we can write CF. So AE greater than CF. Since OE and OF are perpendicular on AB and CD, so we can say triangle OAE is right angle triangle, and also triangle OCF is a right angle triangle, and OA and OC are hypotenuse in both of the triangle. Now from Pythagoras theorem we can write OA square from OAE triangle, OA square equal to A square plus OE square, and from OCF triangle OC square equal to OF square plus CF square. Now একটু লক্ষ্য করি OA and OC both are radius of the circle, so OA should be equals to OC, so we can write OA square is also equals to OC square. Now if we replace OA square, that is OE square plus A square, and OC square by OF square plus CF square, then this is becomes like this equation. Now if we take CF on the left side and OE on the right side, now it becomes A square minus CF square equals to OF square minus OE square. Earlier we have proved here that OE greater than CF. So AE greater than CF. So AE square minus CF square also should be, AE square should be greater than CF square, and now AE square minus CF square should be positive, that is greater than 0. যদি এই লেফট হ্যান্ড সাইড গ্রেটার দেন 0 হয়, অবভিয়াসলি দুইটা যেহেতু ইকুয়াল তাহলে অবশ্যই OF square minus OE square is also greater than 0. So OF square greater than OE square. Now the square is greater than, that means obviously the main term, the square root is also greater than, that means OF greater than OE. So OF greater than OE means OE is less than OF. That is, larger chord is nearer to the center than smaller chord. That's how theorem number 5 is also proved. So boys, on next class we'll do another topic from your book. I hope this is very clear to you. See you on next class.